All right, let's look at the homework 10.4, problem number 3. All right, so let's use the ratio test to find the radius of convergence. All right, so we're going to take the limit as n approaches infinity. Absolute value, right, an plus 1, so you have quantity x minus 2 to the n plus 1 plus 1, so n plus 2. And over, you have n plus 1 would be n plus 2, then 9 to the n plus 2. Alright, then we need to divide by an, so we just take the reciprocal of that and multiply. So quantity n plus 1 and 9 to the n plus 1. And then you have quantity x minus 2 to the n plus 1. Right, so we got that. Right, so we can cancel x minus 2 to the n plus 1, and we're going to have another x plus x minus 2 left over on top, and 9 to the n plus 1, and then you can cancel that, but there's extra 9s remaining on the bottom. All right, so we can pull those things out. So you have absolute value of x minus 2. It has nothing to do with n, so I'll just pull it out since it's a constant. All right, 9 is also a constant. So what's left is limit as n approaches infinity, and we have n minus 1 left over on top, and then you have n minus 2 left over on the bottom. All right, so that we can use the trick we've been using, so we can divide top and bottom by n. We can get absolute value of x minus 2 over 9, and we take the limit as n approaches infinity. N divided by n is 1, and 1 divided by n is 1 over n. N divided by n is 1, 2 over n is 2 over n here. Alright, then we know that the 1 over n approaches 0, 2 over n also approaches 0, so it's a 1 over 1, which is 1. So we get absolute value x minus 2 over 9, right? To get a convergence, we have to make sure that this ratio has to be less than 1. So we can multiply through by 9, so absolute value of x minus 2 is less than 9, right? 9 is the radius of convergence, right? So let's type it in. So we get 9. Let's check the answer. All right, it came back, and looks like we got this one correctly. All right, that's it. I hope that this was clear.